let's write a program to display Armstrong numbers between two intervals. Hash include stdio.h, hash include math.h. Here I'll write my function void arm_num, right? And my receiving parameters will be int x and int y. So I will say int count equal to 0, and let's say I declare I here. So now I can write a for loop. For I equal to x, I less than equal to y, because x and y will be my interval, the beginning and the end of the interval. I plus plus. Here I will say while temp. Okay, so let me also declare temp, right? And temp is equal to I. While temp is not equal to 0, increment count, and then temp is equal to temp divided by 10. So now this while loop will count the number of digits in temp. Okay, so now my temp is modified. I want my temp equal to I again, so I'll say temp is equal to I, and here I'll say sum, int sum. Sum is equal to POW temp mod 10 comma count. So this is temp mod 10 to the power of count. Temp mod 10 is the 0th digit of the given number. So we have to count the individual digits and then to the power of the number of digits, in the sense the order of the number, right? So plus POW temp mod 100 minus temp mod 10 by 10 comma count plus POW temp mod 1000 minus temp mod 100 by 100 comma count. Okay, so the limitation of this program is we can input 3-digit numbers, only 3-digit numbers as our intervals x and y. And now I will check if sum equal to I, printf percentile d I, and then I want to reinitialize count to 0 so that when it iterates again it can count the number of digits in the number in that iteration. Right, now I'll write my main function, int main printf, enter the interval limits. Okay, scanf. Okay, here I have to declare int a comma b. These will be the limits of the interval. Scanf percentile d ampersand a comma ampersand b, and then I will call my function armnum, and my passing parameters will be a comma b, and then return 0. Let me save and run the code. Enter the interval limit, so I will say 1 to 1000, and these are the Armstrong numbers in between 1 to 1000.